So encoding is working, which is superb. So did the compiling of Haskell IDE engine finished? Probably not. Haskell, yes, this one. Buildings and building. So I've already tested, and the parsing is working. Yes, so yeah, we just need here input text. Yes. Delete byte string. We have text stack GCI main. Just call main. Nice. It was red. That's perfect. Let's start actual development. So. What we are saying is we have libhs file, and we have input. First we need to define let's say we input text, but we want to have a copy of input text, a golden, which is a golden copy, which we will not touch, but here we will do some starting with starting with this. We want to parse one single historic moment. Of strings. Yeah, sounds good. And deriving show. Yes, that's all for now. Let's see if we start. So to do this, we need to parse a string. This one. I'm not sure whether it's good to leave this separator inside historic moment or outside. So I will leave it outside. I want to have control upper in this time. So that means that here we have just strings separated by character, maybe new line. Okay, let's say they're separated by new line and vertical bar. Parser characters or combinators. So I need combinator Many, and I need to read set by and by. Parses 0 more occurrence of p separated and ended by separator. Separated and ended by separator. So no, here I want many. Actually, I can use just string. No need for using character. So string, and then we read line. So part 6 has the same concept, meaning that same concepts, meaning that you will need separator to be inside to understand when it's ending. Or maybe not. Let's say, do we have munch or something like that? Many till. Yeah, many till another vertical bar seems to work, but maybe set by will be the best choice here. Yeah, it sounds just better, because you don't need to use many till, you just use set by. But separate by symbol? What symbol? It's from character, probably. Okay, so what we want to do is to use set by. We want to say string any number of any token, right? The parses any token accepts any kind of token. It's, for example, used to implement end of. No, that's not what we want. We kind of want I'm not sure what I want. So we want any characters, right? So we want many any characters, right? Any token or any character, any char, chair is from character. Any chair and separated by string end of the line, right? There is something like that. Go to the contents, go to the character, end of line. End of line followed by string vertical bar. End of line. Okay, that's historic moment for you. So now what we want to do is to say that file is actually historic list of historic. No, it's just a historic moment for now. Historic moment. And we just say, yeah, historic moment. Will it work? Let's see. There is no combinator many. I believe there is. There is many one, but not there is no many. One or more times. Return the list of return values. That's interesting. Commonly used. Skip count separate by one many and by either p. Okay, seems to be useful. And yeah, especially because there is no many here, there is only many one. Let's use parser combinators. Control applicative combinators. That's strange. Oh, I see, because it's for any applicative. Interesting. That's interesting. Okay, let's use parser combinators. Package YAML parser combinators. Okay. Stack GCI, GHCI. And here we'll need use yes, instead of combinator we can just use control applicative combinators. Many, okay. We still need to use any character and so on. Couldn't load lib. It is a member of the hidden package. That's super strange. Text parser combinators. That's also strange. Set by. Okay, fair. Because set by is part of here, right? Set by. Super. couldn't match character with a historical fair, totally fair. Couldn't agree more. What you want is for sub by to say historic moment for this thing you are doing. Yeah. Ah, right, because it's fmap, not just. Oh, it's actually loaded. Okay, so main. Historic moment, and it has only one line for some reason. Yeah, because if you parse with any character, you will receive only this one, right? Because you said, please, greedy, take as much as you can. So what I actually want is the choice. So I want first to read separator and then the parser, but I also want to parser to finish. So I kinda want to it would be nice to have the concept of incomplete parser, or like parser that will take some symbols and it can end. I can use, like, say, I can say that not any character, but all characters except vertical bar. But what if my constraint is not some specific character, but rather some string or more complex thing? And because of that, to try to apply separator. If it fails, go to the parser, and then when it fails, then it fails. Let's read more about what kind of combinators we have here, but I'll need to Google probably. One or more. Optional, empty, between choice, count, either P, combines two alternatives, and bicep by some till, and works similar to many till, but should succeed at least one. Okay, fair, sub by, sub and by, skip many, skip some. Okay, Haskell, parser combinator with sub by with greedy separator. No, actually I don't want sell by, I want sub by. Oh, non-eager. It doesn't, because sep by eagerly descends into another sep iteration which it sees a space character. This can be solved by adding try to sep by to make the non-eager variants. Okay, let's try to create what I actually want, and then we see if there is a similar function. So in the source, let's see how separate bar works. Sep by 1, fair, sep by 1, lift, p many sep by. Is it possible that parser that standard library is the same parser combinator? Is like parsec, so they will have the same speed. Maybe my approach to parsing is incorrect. It may be. So yeah, it says many separate and then parser, which is fair. So yeah, my idea is that my parser wants to output many possible parsings, and then the outer parser wants to choose one of them, meaning the smallest one, the smallest string, and to read separator. That's how it works. And if it doesn't work, like if we read separator and then something doesn't work later, we want to try another one when separator isn't there. Actually it doesn't want to. So basically on each topic I want to try to read separator. And if it fails, I want to accumulate the character. That's kind of separation that I want to do. Haskell parser combinators split. Is for finding text patterns, replace megaparsec, and also replacing or splitting of the found patterns. This activity is traditionally done with regular expression, but replace megaparsec use megaparsec parser instead for the pattern matching. That's cool. Split strings with split cap. Find all pattern matches, capture the matched text and the parsed results. Separate the input string into sections which can be parsed as hexadecimal number with prefix chunk, then hexadecimal. Okay, and then you can split cap, match hex parser, which is cool. Split cap. So that's actually cool, right? It's Yeah, that's cool. Let's also go to replace mega parsec. I already replaced mega parsec. Split. Resplit or parse. Resplit is regular expression split, right? Split string by the occurrence of the pattern. It captures parentheses are used in patterns, and the text of all groups in the pattern are also returned as part of the resulting string. So we say regular expression word plus few words. No, it's not word, it's a letter. And it finds words. But that's not exactly what I want, right? I want to have a separator. Okay, so I can say split and I give a separator and it will return me all separators, right? Actually, the last one, resplit, it's actually says find me please letters and it outputs 039, so it seems like really good, but I don't understand why it's doing like that. Maybe it's because ignore case. Nevertheless, let's use replace parsec. Okay, let's use mega parsing. Yeah, so Haskell parsers have a nicer syntax than regular expression. Yes, can do group capture or section. Okay, I think substring parser match replace substring with the parser combinators. Strange that I don't have a link to the functions. Like to the model to see all function inside. That's strange. Okay, I don't need this one. maybe let's use megaparsecs then, if it has what I need. Take a look at the tutorial of megaparsec. Okay, I will take a look. This megaparsec tutorial, which originally represented as chapter intermediate Haskell, due to lack of progress with the book in the last year, other authors agreed to let me publish the text as a standalone tutorial so people can benefit at least this part of work. The toy parser combinators developers chapter. Parsec has been the default parsing library in Haskell for a long time. The library is said to be focused on the quality of error messages. It, however, does not have good test coverage and is currently in maintenance mode. Okay. AutoParsec is a robust, fast parsing library with focus on performance. It is the only library from this list that has full support for incremental parsing. Its downsides are poor quality of error messages, inability to be used as a model transformer, and limited set of types that can be used as an input stream. Trifecta features good error messages but is under-documented and hard to figure out. It can parse string and byte string out of the box, but not text. Megaparsec is a fork of parsec that has been actively developed in the last few years. The current version tries to find a nice balance between speed, flexibility, and quality of parse errors. As an unofficial successor of parsec, it stays conventional and immediately familiar for users who have used that library or who have read parsec tutorials. It will be practical to try to cover all of these libraries, and so we will focus on megaparsec. More precisely, we are going to cover the version 9, which by the time this book is published, it will probably have replaced the older version almost everywhere. Parsec T and parsec monads. Okay, I am familiar with these monads. Custom error component, type of input stream. Void. I thought so. ESMA. It's not summa, it's ESMA. E is the type of custom component of error message. If we do not want anything custom, we just use void. Sure. S is a type of input stream. Works out of the box with string, strict and lazy text, and strict and lazy byte string. Nice. M is the inner monad. Sure. A is a monad value resulting of parsing. Fair. And we have parser, which is parsec void text. Void text. Nice. So we can use actually parser identity or even either maybe. It has been said that megaparsec can work with 5 types of input streams out of the box. Strings. Yes, it's possible because the library makes these types instances of the stream. Type class, assume a stream. Okay, stream. And doesn't matter that much. And these modules contain 2 similar sets of helper parsers, such as new line and end of line. Let us introduce a couple of primitives on which these models a bit so we understand the tools we are going to use. I don't really... token. Satisfy. I'm not really interested, I believe. Okay, satisfy is monad parsec. Takes monad parsec, token function. Okay, I see the point. Yeah, actually token might be useful. The first primitive is called token, corresponding it allows us to parse a token, and token S is a character. The first argument of token is a matching function for the token to parse. If the function returns something unjust, that value becomes the result of parsing. Nothing indicates that the parser doesn't accept this token, and so the primitive fails. Second argument is a set from the containers packages that contains all expected error item to be displayed to the user in case of failure. We will explore the error item when describing parsers. To better understand how token works, let us see some definitions from the text megaparsec model, which contains, among other things, some combinators that work with all types of input stream. Satisfy is fairly common combinator. We give it a predicate that returns true for tokens we want to match, and it gives us a parser back. Fair, understandable. The job of test token is to turn the f function, return pool, into function that returns. Doesn't matter. With satisfy, it does not say what is expected when it fails, because we cannot analyze the function which the caller of satisfy provides. There are other combinators that are less general, but they can generate more helpful error messages. For example, single with type constructed synonymous called character, which matches a specific token value. The token data type constructor has nothing in common with the type function tokens that we have discussed previously. In fact, tokens is one of the constructors of error item, and is used to specifically concrete sequence of tokens we expect to match. New line. Chunk. String. Okay. Monads and applicative syntax forcing consumption input with end of it. Applicative is often powerful enough to allow doing quite interesting things. Equipped with an associative operator which has identity, we get a monoid of applicative functors expecting Haskell via alternative type class. The parser combinator package provides quite a few abstract combinators built on the concept of applicative and alternative. The text megaparsec model exports them from control applicative combinators. One of the most common combinators called many is run given parser 0 or more times. Most of the time we want to actually force parser to consume entire input and report parse errors instead of being shy and stopping silently. This is done by demanding that we reach end of input. Happily, although end of input is nothing but a concept, there is a primitive called end of phi that does not over-consume anything and only succeeds at the end of input. Let us add to our parser, okay? Working with alternatives. So, okay, it's fairly similar. So, lexing is the process of transforming input stream into a stream of tokens, integers, keywords, symbols, etc., which are easier to parse than raw input directly, or are expected as input to parsers created with parser generators. Lexing can be performed in a separate path with an external tool such as Alex, but megaparsec also provides functions that could simplify writing a lexer. Okay, I don't need lexers. Megaparsec is similar enough, so I can start with it right away. re-exports. Note that we re-export monary combinators from control monad combinators because these are more efficient than applicative-based one. Thus many and some may clash with the function from control applicative. You need to hide the functions like this. Okay, fair. State, so run parser or parse. Okay, so what we will do here is we have package YAML, and instead of have parsec, we will have mega parsec. We will leave byte string and text just for any interesting. So we don't need text parsec, right? We need text mega parsec. But we still have parsec, or we have parser, right? Type. We also have parsec, sure, but parser. It's common to start working with the library by defining a type synonym like this. Okay, so it's okay. Fair. Type parser is parsec, void, text, and identity. And we need to import data void. Let's see how does it work. Text mega parsec. There is no. Yeah, sure. We need to reload. Yeah, there is no text parsec char anymore. Contents. And now we have text mega parsec char. Could not find text mega parsec. How so? Hey, it should be here. Mega parsec, text mega parsec. Right? KM. Text mega parsec. Are you saying that there is no parsec here? But there is. Couldn't find model text mega parsec. I see, because parsec is not. Yeah, it's with lowercase. End of line. Fair, any chair, fair. Let's have only string for now. And let's say many character, any character. Yeah, we don't need this. Let's say just string for now. Identity. What? Oh, wait, parsec is already with identity. Yeah, I don't need this. String. Couldn't match expected type tokens with actual type character. Because it's not parsec here, it's parser. Same here, it's parser. Parser historic moment. What about still building? I'm not sure how much you can build. Text with string. Fair. So you want this one to be a list of text. Void text identity. Okay, so it says tokens text. Couldn't match type text and the list of text. Oh, fair, because we don't have separate by. Yeah, that's totally fair. Return something. That's strange. Couldn't match type character with text. Okay. So what I can do is to say text. Right? Should work. Couldn't match expected type text with actual type character. Wait, I'm using overloaded strings, right? Strings. Package YAML and extensions. Stack default extensions. Stack set language extensions. Yeah, I will try to modify for extensions. Reload GCI. No text parsecs in the main. Oh, great! It's compiled. Superb. Let's go for main. Why do you need text parsecs for? Okay, text mega parsec. Nice, good. What else do we need? So now I want to split. Is there something about splits? Oh, that's not something. What we need is mega. Replace mega parsec. Yes. Okay, what function it does have? Let's say for text. Separate cap text and separate til text. This entire model is for text specialization. The function is in this model are intended to be chosen automatically by rewrite rules in the replace mega parsec module. Oh, okay. It's specialization, but we have general functions here. Okay, running parser. Functions in this section are ways to run parsers, like run parser. They take an argument, a separate parser, and some input. Run the parser on the input and return result. That's not ideal. I want to have it as a parser rather than running a parser. Okay. A function in this section are parser combinators. They take a SEP parser, find an argument, combine SEP with another parser and return a new parser. Cool. Anytil. Nice, that's what I need. So it takes anything until the separator, right? Yes, that's actually what I need. I'm not sure why it... tokens S. Okay. SEP cup. Parser combinators to find all of the leftmost non-overlapping occurrences of the pattern. Parser SEP in the text string. Parser combinator to find all of the leftmost non-overlapping occurrences. Leftmost non-overlapping. The SEP cup parser will always consume its entire input and can never fail. SEP cup is similar to the SEP family of parser combinators found in parser combinators and parsers, but it returns the parsed result of the separate parser instead of throwing it away. The input stream is separated and output into a list of sections. Sections which can be parsed by pattern SEP will be parsed and captured as right. Non-matching sections of the stream will be captured as left. Cool. Wait. But either can be either right or left. How it can be separated? I see, it's a list of eithers. Makes sense. That's actually what I need. Yeah, SEP cup. Yes, so what I want to do here, a SEP cup is part of replace mega parsec module. Okay. SEP cup, and I define string. Let's see, should I define as new line? Yeah. Let's say text mega parsec character, and we want a new line, end of line. Oh, end of line. Parse CRLF or LF, new line. Nice, nice. End of L, that's cool. Character, end of line. String. Okay, I think that's fair. What we also want is to say string this one, because we start with it. We start with vertical bars, then we say separators, and sep cup returns list of ithers. So what we need is to actually list of tokens. So we can just take all lefts, right? Hugel. Actually, I should be able Hugel, and we want a list of either A, B, and we want just A's. What? There is no such function? Are you sure? Okay, I can do like filter by lefts. Yeah, there is such function in data others. Super. So I don't care about delimiters, separators. Import data either lefts. Yeah, so I will do lefts, and that would be my columns. The only thing that it will be tokens as, and I need to understand what does this mean. So tokens as. Could I convert tokens as to something? Is a type. Okay, so basically token as here is text. Okay, so if tokens as is a text, then I can just return, because historic moment is a list of text, right? So when I have, say, only lefts, it will be a list of text. Let's try. There is no replace megaparsec. Interesting. Replace megaparsec. Okay, because I need to reload probably, right? I added replace megaparsec. Yeah. So string, there is no string, you say. And what's there in character? Wow. wow, a lot of characters. String, there is... it just I hasn't imported it, probably. Chars, no, it's here. Variable, wait, string, sure, string. Are you kidding me? That actually worked? Super. So, oh, it's finally built. Nice. So maybe Vim right now will help me. Okay, let's open Vim. For this sake, input text, and we will have lib. Nice. We now have semantic support. Oh, string prime is case insensitive. Yeah, that's also nice. Yeah, mega parsec is better than parsec. Okay, so now that we parsed with new line, which is a bit strange, right? After 5 we have new line as an element, and for some reason not everything parsed, right? Only this one parsed. Yeah, for some reason not everything is parsed. End of line and string. So what we should have here is find of range city. Oh, you have control, yes. Then 5, yes, and then /n, but then another /n and another no, no /n, because we want to be something like that. Minus /n. How so? Oh, I see, because there is no space between, so it doesn't... Okay, that's a nice way to say that we don't need end of line, we need just string. Yes, we just need string. Then everything has new line, but that's okay. We will trim if needed. Okay, I kind of wanted to have empty strings. Maybe this library even thought about my use case, so I can sepcap, right? Sepcap. Oh, split cap. Split on and capture all patterns. Find all occurrences of the pattern sep. Split the input string, capture all the patterns and the splits. The input string will be split on every leftmost non-overlapping occurrence of the pattern sep. The output list will contain the parsed result. Oh, the thing is doesn't output parser, and we don't need. No, we actually need, because split cap is a running thing. And we want to reuse parsers. Sepcap, C sepcap for, okay. Separate and captures. The output list will not contain two consecutive left sections. The zero width match is forbidden. If the pattern match in parser sep would succeed without consuming any input, then sepcap will force it to fail. Okay. Okay, so what's going on is that after filtering in separators, I will not know when there is two separators. I want to input empty string. That's what actually I want. So I can do this by using group by. Yes, because if I separate by vertical bar, it means if in the message there is vertical bar, I will split by zero. But I actually end of line and vertical bar. So I need to solve this problem that if we have two consecutive separators, we will see how this problem can be solved. That's an interesting question.
Non più tra i farfalloni
can
amoroso, notte giorno di torno girando, delle belle turbando al riposo, Narcisetto a dolcino d'amor, delle belle turbando al riposo,
The problem is that the list
Narcisetto a
cannot
dolcino
increase the
d'amor.
number of elements.
Non più avrai questi bei panacchini.
Okay, I can zip this with...
Quel cappello leggero galante, quella chioma, quell'aria brillante, quel vermiglio d'onesco color, quel vermiglio d'onesco color.
What actually I need to do is to do
Quei
some
penachini,
or scan L.
quel cappello, quella chioma, quell'aria brillante. Non più tra i farfalloni amoroso, notte giorno
we
di
also can use
torno
concatenate,
girando, delle belle
Yeah, actually
turbando al
quite
riposo,
good.
Narcisetto a dolcino d'amor, delle belle turbando al riposo,
Okay, I will make it less loud. I cannot make myself more loud, but I can control music. So that's what I will do. I will use concat map. Wait, why it's not enabled? Here Lisp, LSP. There is no here. Interesting. So even after I installed. Wait. Arch Haskell IDE engine. So what does this package does then? Arch Haskell IDE engine. Haskell installation with Arch Linux. Aura A Haskell IDE engine. Yes, that's what I did. Yeah, so where is my Haskell IDE engine? The command isn't found. Command not found. Tip: you can quickly check if some command is in your path by running the command. If you receive some... So do I need to add... Oh, I see, I need to add stack pass. Stack pass. Do I have here in variety? I have variety, but not stack. So where can I get here? Bin. Local bin pass, okay. Bin pass. Oh, stack pass. Bin pass. Stack pass help. Bin. Local bin pass. Local bin. Bin pass. Okay. Stack pass. Bin pass. Dun, 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 dun. So you say that there is no here. Yeah, this. There should be something that compiler bin. Stack pass compiler bin. Okay, yeah, let's go there. No, we don't need compiler bin. We need build binaries. Stack pass destination directory. Da 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 da. Da 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 da. Mm. Mm. Mm-hmm. Programs, stack, pass programs. Wait, let's go to our package. Haskell ED engine and see what it does. View package build. So the package name for var stack YAML build. Okay. Install package dir user share license package name license stack YAML local bin pass. So it should have been installed the user bin here. Okay, so we say user bin here. Okay, we have. That's really nice. We have different versions, but not 6, 8. Okay, let's say we want 883. Sudo lns user bin here 883, and we want it to be just here. Is it fair? I think yes. So now yeah, we'll need to restart probably. Input text. Okay, so we have here tokens, and we want to concat map. We actually want to zip and then concat map in the way that if we have two separators together, we want to output separator and empty. Oh, just empty. And if we have just separator, so let me show you. Here we have tokens, and what we'll do, we zip tokens with with tail tokens, but the thing is that we need, it will be the list with one character over, so with the last character not inputted, so we are saying that we 100% taking the first element. Not necessarily, because if the first element is we 100% take the last element. Not necessarily. Depends on whether the first and last element are separators. Okay, so we know for sure that there is no two parsers together. There is there only can be two separators together. So because of that, we can make some assumptions. Maybe we can use them to do it easier. So we can group by parser, by left. So we have now list of ithers, and we know for sure that we will not have two lefts, consecutive lefts. We will only have two or more consecutive rights. And what we want to do is to, if we have two or more consecutive rights, we want to input between them empty left, like left with empty string. So what I think we can do is group by, and group by saying that everything should start with separator, not separator, and everything should end with separator. Yes, and if group is consistent only of separator, it should have something before it. Yeah. So let us test my understanding of how group by works. Import data list group by. So if we have the list of equality, let's just start with equality, and we have list of, let's say 0 is left and 1 is right, and then we have consecutive ones, and then we cannot have consecutive zeros. We will have only, for example, this list, and it's grouping by equality. So it will take an element, try to apply function to the next one, and see if the function returns true, it will group them. If not, it will not, and it will check the first the element with every subsequent. So what it will do is, for us, we need to say if the left element is 1, so we have previous and next element. If previous is 1, then it should be false, so it's not equal 1. If we do something like that, of course everything will go with 0, because it will take 0, it will try to apply function with 0 and all other elements, and because we only say that our only constraint is not equal 1, it function will always output true and will take all the entire list. What we also need to say is that it's not equal 1 previous element, but also the next one is not 1. Actually, we can take 1, 1, 1. So I want to group it by 0, 1, 1, 1, 0, 1, 0, 1, 1, 0. I want to group it this way, but it's really hard to understand whether you've taken one line. So the function will output the same for 0, 1 and 0, 1 was it. So 0, 1 on the second place and 0, 1 on the third place. It will have different results. And so group by cannot understand where to finish. What we also can do is to say don't include new ones. Right? So we say new doesn't equal 1. Yes, that's a bit different from what I've described, but that's suitable for our needs. Every separator is in separate group, but if it followed by 0, it gets in the same. And if we have one first, it will have separately. So now what we need to do is we say, if we have group with only one separator, it means the next one is also 1. Meaning that we want to add something after this. So what we'll do is group by n is not equal to 1, and okay, it's a bit harder function, so I will not go into details here, but yeah, my idea is works, and that we just do this group by and then add 0 where we need. Then we can actually we might not add 0, but we actually can replace. If it's just separator, just replace with 0. If it's not just separator, then drop the first one, because we know that only the first one can be the first. Okay, sounds good. Yes, sounds good. So we have here tokens, and we want with them is group by this rule of previous next, and next shouldn't be only. We need here the function from data either is JKLM, so I before is left and is right. So we want to group by is right n. So left is and can be only once, is right can be twice. Yes, so we are not is right. So is left, we can say. So yeah, we say until it's left, please take into the group. Okay, is left. Yes. And then we will receive groups which start with right. In case it starts with right. So we will say map. And the thing is that if the we will need to say let here and say that, or we can say where also, where insert empty or intercalate. So insert empty if, okay, so we have one case is when we have only one element and it's left. If it's right, if it's right x, then we just return right x. We don't modify anything. We actually can say x like this and return x. But if the first element is left, wait, right is separator. So if we parse somebody, we just return it. But if it's just separator, okay, so we need to input something only in case. Only in case we have separator which is right, single separator. In this case we will return left empty, or rather we would add something. Yeah, that sounds good. So we will replace, but then if not, we just return what we've got. And then we say concat map insert empty. We actually say concat map. Not. We say map and then concat. Yeah, because it's not concat map. Yeah, concat map is a bit different, I believe. Concat map is A to B. Yes, and we have functions that list of B's into list of B's, and then it outputs list of B's. Oh no, it's actually working. If we say that A is a list of B's, then we get the function list of B's into list of B's. We will have list of B's, and it will, yeah, it's actually working. And concat map insert empty. And we say just lefts, because that's what's interesting now. That's what we are interested in. Concat doesn't work. Data text concat map. Yeah, I see. Yes, let's import text as qualified to disambiguate text. Yes. Something else. Group by is not in scope because it's from data list. Oh, couldn't match types. Expected type will return the list of isers, but actual type is iser something. Insert map. So you would expect insert map to take either one iser text or iser text and return list of either text or b1. Actual type returns just either and doesn't. I need to return list here. I forgot. Couldn't match empty list with parser. Expected type parser historic moment. Actual type list of historic moments. In the expression historic moment, I can just do return. No problem for me. Right, because subcap it returns text, right? Yeah, it works on tokens, so it should return here. Hahaha, it's actually worked. So let's just compare 5 empty string, empty string, empty string, and minus /n. Empty string, empty string, empty string, minus. Yes, that's exactly what I need. Great. So that's great, but then we want several historical moments. Golden txt, and let's say we have several historic moments separated by a separator. Like this. Okay, so we add in separator vertical bar dash. So to add it, we need now have historic moments. Or rather, let's say it's not historic moment, it's era. We don't need actually type for historic moment or something. It can be just a list of historic moments. Like this. Historic moments. Parser list of historic moments. Okay. Moments, and we say that sep cap and separated by end of line and our separator. Right, that should be it. Yeah, I think. Actually, we can even say end of line string spaces. Alright, we have spaces. Space. Skip 0 or more white space character. Yes. We say space and vertical bar. That's what separates different historical moments. I also can say, oh no, we start in historical moment with a vertical bar. So in this case, we say that we don't need this one, but we might need space. Yeah, and space will include end of line if needed. If space includes end of line, and doesn't matter. Yeah, we want exactly end of line. We don't want if this symbol is inside some text, we don't want separate by it. And this will return a list of left and right. And we want only lefts, because left is actual parsing. Should it work? Space. Yeah, I didn't include space. Sep cap. What's wrong? Yeah, we didn't use historical moments at all. Right. Because we need to run parser on what? Oh, because left is a list of tokens, or rather tokens. So what we need is to, for each of the left, we need to apply historic moment parser. So we have function parse. We don't. And what I'm using in main? Function parse from text megaparsec. Which takes string as source name. Okay, string, tokens, and returns either. No. We also have run parser. Run parser takes string s and return either as well. Interesting. So if I have text, I will need to run parser on the text separately. Yeah, let's do this. Map run parser. Only what we need here is run parser should have arguments, and the first argument is historic moment. I'm not sure why do we need this source name. Historic moment. And what else it does need? And so we need to somehow to output either. What about run parser t? It also uses parser error bundle. Either, so I don't see the benefit of it. Oh, we have lift. The thing is that because we parser t is because parser t is trans monad, we should have lift st. Is it st? Lift. There is no lift. Lift them. Oh, I forgot. Oh, maybe it's stm. All monad stm. I don't remember. So there is the way somehow to lift one monad into the transpose traverse. No. How do you go? Trans monad lift or something. Control monad trans. But you MTL, I see. And you have lift, which lifts MA into TMA. And that's what we need actually. So let's import TML and transformers. Okay. Maybe MTL. Okay. Package dependencies mtl. Oh, it will take some time. I already installed mtl. Okay, couldn't match type text and historic monument. That's okay, that's fine. What we need is a lift, because run parser will result in either. So what I want is lift either to parser monad, and not only I want to lift, I want to concat ithers, right? So I want the function that will take list of ithers and will concat them. I think that's mconcat. Left 4, left 5, right 6. What? Either is not monoid? What is either? Functor applicative monad. Okay, monad. I want sequence. Left 4, left 5, right 1. Yes, that's what I want. And if everything is right, then it will output list. Yes, that's what I need. So we have map. Oh, we don't need to have sequence, because there is a map m with sequence, something like this. Yes, here it is. Only map m. Hallelujah, hallelujah, hallelujah. Map m doesn't matter. Map m, and it will run parser, and then it will concat either into either of list, and then we want to lift the result. That's quite. So you don't know where lift. That's fair, because you need control monad trans class lift. Import control monad trans class lift. What? Hidden package transformers. Okay, maybe I need transformers instead of MTL. Couldn't load more run parser, right? Because run parser yes, I want. It's in the text megaparsec. Lift. No, run parser. What? Not replace. Yes, my bad. It's just text megaparsec. Text with character. That's yeah, makes sense. In the second argument of that's interesting. Sep. Oh, right. Because I wait. Here string is output as text. So I'm not sure why here string. In the second argument of fmap, namely separate, so actual type is either text, expected type either string. I'm not sure why it's expected like that. Because we have left run parser. Once again, run parser. Once again, run. Wait. Import text megaparsec. Run parser. Okay. Run parser. Okay, you need parsers and string. I see the problem. Wait. I didn't give the parser. Historic moment. Then string. Then yes. Wow. That's interesting. Expected type parser. Actual type is parsec t transformer. Wait, t0. Parsec t is a transmonad, right? Parsec t. That's why it's t. It has t prefix and then suffix. It is monad trans, right? Monad trans. Actually, it's not. Surprise. That's unexpected. Parsec t. No, it's monad trans. I'm not sure why it's not written here. Should I import some class for this? Oh, because it doesn't have lift function, right? Because standard lift function is not defined, so I actually import lift from control monad trans class. So it should take any monad. Oh, I see, and it will put not identity but either. I see. So it shouldn't be void here. It should be this standard error that run parser gives. And parse error bundle. Parse error bundle S, or should it be parse error bundle E? Wait. It should be either parser or bundle. That should be the monad. Yeah, G text and E. Wait, what's E? E is some state, right? Yes, E is a state, so parsec yes. No, E it's error, S is a stream. E should be something of parsec. Wait, what should be E? You say it can be any error? Or I guess any error that is allowed by parser error bundle. That's combinators. We need the primary megaparsec package, and we will have here parse. No parse, run parser. Yeah, we have parse here. It's just without. I see. Because it has comments in the type. I wasn't able to find it. So we say parse p file input runs parser p over identity. C run parser. If you are using the parser t monad transformer, parse itself is just a synonym for run parser. It returns either parse error bundle or a value type. Error bundle pretty can be used to turn parse error bundle into a string representation of the error message. See text megaparsec error if you need to do more advanced error analysis. So I don't need, but I want to convert this error parse error bundle so when I define the parser void text, parsec void text, what does it mean? Parsec parsec run parser parsec void custom error component. Okay, I don't need custom error component, so I will put here void. So now when I have either, I don't want to have either here, right? I just want parser and bundle, or do I want to have either? Let's read about parsec. Parsec is a non-transformer variant of the Moderno parsing. So ESMA custom data component of error E. So I would say that either parse error bundle will be my error. Can I say that? Probably. Because I want to lift actually let's see how the lift is defined for Wait, so monad trans. We say that we can lift monad into... Oh, I see. You cannot use parsec here. You want to have void here. Там можно... no. Губернаторы. No? Количество. Потому что теперь Even. Okay, so okay, so we stopped on trying to lift either error into the parsecti monad. So we want to have parsec. Okay.
cappello, quella chioma, quell'aria brillante. Non chiudrai farfalloni amoroso, notte e giorno di torno girando, delle belle turbando al riposo, ma ci sento a tuo giro d'amor. Delle belle turbando al riposo, ma ci sento a tuo giro d'amor. Fra guerrieri per bacco, grande stacchi stretto sacco, schioppo in spalla, sciabla a fianco, collo dritto, uso franco, un gran casco, un gran turbante, molto onor, poco cantante, poco cantante, poco cantante. Ed invece nel fandango una marcia per il fango, per montagne, per valloni, con le nevi e salioni, al concerto di tromboni, di fanfarte e di cannoni, che le porre tutti i tuoni all'orecchio fan fischiar. Non più avrai quei penachini, non più avrai quel cappello, non più avrai quella chioma, non più avrai quell'aria brillante. Non più avrai farfalloni amoroso, notte e giorno di torno girato, delle belle tornando al riposo, ma ci sento a tuo giro d'amor. Delle belle tornando al riposo, ma ci sento a tuo giro d'amor. Che rovino alla vittoria, alla gloria militar, che rovino alla vittoria, alla gloria militar.
Type constructor of parse t. Parser t. That's fair. Parsec t. Parser or bundle, yes, we need. Parser or bundle. It's in text mega parsec. Yeah, because it's not as we know it's text and error. I don't know what should be error here. Ah, void. We don't have custom errors. Okay, that's nice. Historic moment. Couldn't match type either with identity. Sure, that's totally fair. If only... Why? Wait. Why with identity? Why do you expect identity here? Expected type, parsec, actual type, parser, historic moment. What's the difference? The difference is that parsec void... Wait, where is parsec is used at all? Right, I have only parser. Is it in the main? No, lib. Expected type. Oh, I see, yeah, because run parser expect. So what we need is run parser t. Which takes parser string s and returns monad either. Wow, that's interesting. Okay, so we are saying that monad is returned. Parser monad should be returned. Parser monad and inside either. What's the point of that? I actually don't want this. I want just either. So I want to run parser and return either. Why can't I do this? Because parsec is... Oh, I see now. I see. So what we want to have here, run parse t, but then we want to fold. Yes, that's what we want. We want to say run parser t, and we will have either of eithers. Can you do this? Yes, either of either. So it will be a list of eithers of eithers, and we want to sequence. So what we want to have is map m run parser t, right? Okay, map m is traversable, so that's not what we want. What we want is this function, right? The function that takes another function. Yes, that's what we want. Wait, so I don't need to use parsec t, right? I can just use parser as it stands. Parser, okay. So what we are going to say is that we are running parser, we are receiving either and we can handle either. You know, it's not like we need anything. Yeah, the problem with this is that we want okay, no, parser t is what we want to have. The only thing that when we run parser t, we receive either of either, which is fair. I would let's see, maybe we have fancy functions for running. parsers. Parse maybe. Parse test. Parse return parse maybe. Okay, parse test. Run parser. Okay. Run parser. Parser t. Okay. Any single but none of much. Yeah, that's good parsers. What we want is to somehow convert a parser trans. Can we unlift? Yeah, if we have trans monad like TMMA and I want this TA. Let's actually Google this. TMA of MA and I want TMA. Seems like simple function. Sure. Actually, it's quite simple. So what you need to do is you need to get MA and you will need to lift MA. That's how you get it. Thing is, why there is no function for this? I'm not sure, but so what we are doing is run parse t, historic moment. But after we will get TMMA. What we need to is to lift. What do you say on this, Elon Musk? Perhaps you mean run parser. Perhaps I didn't. Okay. I understand what you're saying. Run parser. And 17. Yes, I meant parser t here. Couldn't much type either. T1 is parser or parser t. Okay, let's simplify. Because yeah, we need simplification here. So we say sep cup. We say that's lefts. Right, we want lefts. That will be our moments. Okay. So on moments we need to do such stuff. On each of moments we need to run parser t. And that's fair. Oh, actually here moments will be actual moments and not parser. So it's not like you are running... No, you're running historic moment parser. On moments. And you receive either. And you want a pure value. So what you are doing, you are extracting pure value. Yes, and lifting it. So you will have TMA. Yes, map m, you also saying? Yes, because map m will return you a list of isers. No, actually list of values. So you don't need to do sequence, right? Actually, yes. So you can just say map. No, but you need a parser, right? So you're doing sequence because of that. Isn't that right? Couldn't kind with parser t and iser expected type. Actual type. In the second argument of dot, namely run parser. So expected function that takes text and return parser with iser with result iser. That's fair. But here we have function iser, I see, which return iser. Actual function, this returns iser. Yeah, that's my mistake. I actually forgot that. It's iser of iser will be. Right? It's what it says here. Iser of parser. Or iser error or iser again error. Yes, that's actual type. But it wants something that takes parser. No, returns parser. Okay, so let's try without lift. What we are saying that expected type is parser t, actual type iser. Iser historical moment. Oh, we also need to do return, right? Because we are getting here not parser, we are getting actual result. I see the problem. So run parser t will output iser. Iser. Okay, fair. What I want is to... I don't want to lift, right? So I want to have sequence here and lift. But I want to have mapm. Yeah, and I will have here iser list of isers. But I want also here to iser to fold on itself, meaning I want to do this, which is definitely seems wrong. MA into MA should be something like fold. Join. Cool. Control monad join. Nice, we come to main. So now main expected type parsec. Couldn't match type either with identity. Okay. Because parse is for yeah, because parse taking parsec, and when we what? Yeah, parse taking, and we want parse t, or rather run parser, right? Run parser t. Nice. Historic moment. Okay, it didn't parse two historic moments, it parsed one big historic moment. Interestingly, why? But that's progress. At least we know how to leave monads. Let's try to remove spaces. Maybe that's the reason. No, still, we have only one historic moment. That's a bit weird. Ah, no, file. Right. File doesn't use historic moments. What can I say? Nice. Sure, it actually works. Interesting /n in the end. Like we are saying that one of elements is /n. Yeah, I think that's because we have two /n's in the end.
Kan aku tidak tahu harus seperti itu. Kita ulang lagi sekarang. White power.
Cool that Raina is speaking English and Japanese. Okay. So now we are going to read error. Only let's finish error on some moment after two historical moments. Yeah, like that. Okay, so after retrospective, it seems like parser combinators are overkill for such simple task, where you need just to split by vertical line and a vertical bar and the figure bracket and so on. Yeah, it seems like overkill because it's too complicated, and parser combinators library isn't built for this. Like, you need to do too much boilerplate to do this. I just want to finish mega parsec option to ensure that it works with OK speed, and then re-implement it using split. The simplest function you can find in any language. Okay, so historic moments work. I need to have I need error, which is parser of error, and error will be error will contain a list of historic moments. And error will be first it will be error fmap do, and then it will be I will need to output this. I will not need only modify. I need to store every information that I found, that I parsed. So I am doing string of 3 quotes. And then I read till something, right? Between. I can use between. Right. Combinators. I want to have combinators here. Oh wait, we have control between. Yes, we have open close followed by p and close. Return the value returned by p. Okay. Between string this and the same string. Between these two string, read any basically. Many char any, or what do I have here? In char, right? Char any char. Is it the basic? And so it's not included here. A synopsis. Wait. Label failure chunk one of single. Oh, single. Yeah, many single. There is single and there is any single. Haskell chunk. Much take and then get input. Yeah, I think it's any single. And it's not in char? Interesting. Yeah, deriving show, of course. And this will be error title, and then we need to have spaces or just space, right? Yeah, just space. Space, and after space we have a string. Oh, between. We have between. Between open figure bracket and between close figure bracket. Yes. And we need to separate them by that's the same stuff will be going here, like moments. Okay. Historic moments. I can just do this. Yeah, so I'm saying between this you have separate by this symbol. Choose only lefts. And say between. Wait. Yeah, map left. Yeah, so here we have blobs. I'm not sure how to. Yeah, let's say blobs. Not descriptive but. Okay, moments is good. And we want here to have header. We also want to have failure, but at this point I don't care about validity. So if there is no header, it will fail. So I will say that you have header and you have moments. And the header should be... So moments should be parsed like this. So I don't actually need historic moments function. Oh, era is not only historic moments now. Era is also a title. The text, yes. It's also header. Text. And its moments. Moments. Moment unparsed. And yeah, moments parts is this. So at this point we have everything, I believe, and we return era. Era, its title, header, and moments. And we say that since historic moments is not used, we want to pass era, and it will be error. What, you don't like comma? Ah, yeah, because second comma here. Between, yes, because it's one of combinators. What? You say that title is string? That's weird. Couldn't match expected type text with actual string in the first argument of era, namely title. Why do you say title is string? Between. Between is applicative, okay? Any single. Not sure. Text, historic moment. Not sure. Couldn't match text to historic moment with era. Expected type parser era, actual type parser t, and some function. That's weird. Title should be string. Header should be string, and moments should be moments. In the expression era. Oh, I see. Oh, right. Since array is not historic moments, you don't need this here. Title. Yeah, I'm not sure why title is could match expected type text with actual type string. Why do you think that title is string? So between is M open, M close, MA. String. Any single is taken as many any single. Yeah, it's any token as. Why it has to be string? I really don't get it here. Okay, let's force here parser text. Oh, so now we say expected type parser text, actual type parser t. String for some reason in the end. Because it string outputs string probably. I see. But if I say I want text, why don't you use text? Couldn't match string because actual type in this main and do. Expected type parser text, actual type is character, string. Why is it string though? Let's try type annotation on here. Right, because it should be parser text. Parser is void text either, text void. So fuzzer for some reason many any single it's token s. So what's wrong? What's token? Token t text. Let's for a second play undefined. Yeah, I really don't understand why it's necessarily parser t-text, because in the GHCI you actually see that any single has m token s, so it's not string, right? Thus between that makes it string. Text megaparsec character any single. It's also token s. Token. What's token? Something. Token text. Okay. Token text char or token text list a. Okay. So we should have token text char. I don't know how it determines that it's string. So string, it's token, right? It's tokens. Okay, maybe tokens is a bit different. Tokens for text is text, tokens for list is... Okay, now we are trying between string and any single. It's tokens. So how come when I try to load? What? I see. Yeah, it's main. Oh, it's loaded. What? Oh, yeah, right, it's compiled because I put undefined here. Some reason if I put here many single is not parser t-text suddenly. Okay, let's skip between for now. Deal with many single. Okay, same error. Okay, let's say any single. Can I be sure that any single is parser char? I see. So any single is indeed parser char, but any single is parser string. It's not parser text. Okay, I understand why it's... No, I actually don't understand why it won't understand it. I won't parse the text. Just to be sure, title will be the same here, right? Okay, cool. So, what many in a single parser character? I'm stumbled. Oh yeah, I see the question. Is it because of overloaded strings? No, we don't use overloaded strings here. So why? So why if I say that let pair equal many any single right. I meant any single. So what I want parse p, and parse has parse p. My string is like source name, and then s, which will be pack 1 2 3. Yeah, sure. Import data text. Nice. So it works here, but for some reason there it's only string. Okay, what will it be if I disable the language extension? Yeah, because we want text and string. Let's put aside everything as much as we can. let's define string as string t. So we need to apply pack, right? No. Yeah, because it will take string and return parser, and it will say pack and string. So everywhere we use string, you know, string t. What? String t lacks a steering. String t pack. Sure, t pack. As you say. Left concat mal insert empty. Wait. Left concat mal. Wait, what? Left concat map ins empty. Alright, right. Because you need to pack here. Or do we have t empty? Yes. Great. Huh. Nevertheless. Nevertheless, title for some reason is char. Ta 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 ta. Why any single is string? Why? I disabled extension even. Yeah, I'm just don't understand. Why do you expect? Why actual type is character? Couldn't match type string with text. Expected type text. Some reason it's string. Alright, because wait, no. Returning type is string. Source is text. Any single. Monad and token S. Wow. How dumb am I? Okay, so the thing is, it's not text because many returns a list. So list of characters. That's why it's string. And okay, that's fair. Let's pack it then. Alright, we need to reload to enable language extension. Oh, nice! No, it's error, right? Parser bundle. Yeah, let's print pretty print or something like that. A pretty print. It's replace megaparsec. I need megaparsec. Print pretty error bundle pretty. Yeah, let's change main to include this pretty. Result, yes. So we want to have either, right? Yes. We want to have either if that's left, we want to have error bundle pretty, and otherwise just print. Should be fine. Only we need to do have error bundle pretty and something in megaparsec error. Good. Error bundle pretty. Print. Oh, yeah, right. Because it gives strings you. So you will need show here. And then put a strlen result of this. What? Because it's either, right? Wait, but I'm using either to say that if it's left. I'm already using either, but let's print res. But result is right left. Wait, run parser t. Run parser. Okay, parsec gives identity. But we don't want identity, we want join. What about parse? I need to run join here, but like I cannot justify why. Right, because I see, yeah, doesn't matter. You can just say join here. Okay, that's really nice visualization. Unexpected end of input, expecting 3 quotes at line 24. Interestingly, that at line 24. What do you expect something at line 24? It's not like empty line is here in the end. So you say between 3 quotes and 3 quotes. Many oh yeah, because many single will take everything. So what you need is many till, right? Main till and applies parser by 0 or more times until parser end succeeds. Okay, many till sounds good, though I'm not sure. Why do you need between then? Not sure as well. Yeah, I'll need to make my own parser library because this one seems unintuitive or something like that. Like too many tricks to do. So what I say is string. And then you say many till expecting it's the same, right? You don't use between, you use many till for some reason between tries to parse. Okay, I can understand. Yeah, I can understand reasoning. It just you don't need to use between and many inside. You need to and here I can't. Right, I'm separating by till. Some till. Wait, some means shoots at least one. So it's not something you want. So what you want is count or something. You want exactly one. So you don't want many till. But because it's set by, you actually want to split. Oh, and by, yes, and by is what I need. Parsers 0 or more occurrences of p separated and ended by sep. But question is, we will try to parse p first, or will it parse separator first, because separator first is what I need. Breakup, okay. But I don't want to run parser, okay. Ah, any till, okay, okay. Nice. We actually have any till, which the parse separator. Consume input until the sub pattern matches equivalent to many till any single. Yes, any till, and we are. But thing is that returning is tokens. So you will need to run parser t to make this join and so on. That's quite unpleasant, quite. Wait, if it's m tokens s, I can lift this and treat this like a parser. I don't need. Wow. I am actually dumb. Okay, I see. Let's leave between for now, because what I want here is to refactor this run parser's key, which is super dumb now that I look. So we have moments unparsed, right? Oh, I see. Monad here is a parsing monad. Wait, but well. Okay, there is no other way than if we got inside the monad text. There is no other way to parse this text except as run parser. And run parser has complications. Actually, a run parser results in identity, right? No, it results in either. That's why we want to join and then lift. Wait, run parser t. Some reason it outputs run either maybe or run maybe. No, there should be something easier. Running parser AE. Parse maybe returns. Why is everything on parsec? Run parser t. Yeah, the only one who works with parser t. So the problem is now is that till end returns text, which is not really nice. What we want to do is that it will return parser. It will take, basically the interface should be the same. It should be separator and parser for element. I see, it cannot run parser. No, it can. Okay, so it should run parser after okay, I give up for now. Okay, not giving up, just making a lot of strange moves here. So we will use many till, okay? We indeed will use any till, but any till, we actually will use many till here. Many till, right? Many till. Many till is... Wait. Many till is, and actually all of the sum till. sep cup. Okay, there is no sep cup here. Okay, I see they re-implemented sepkai using many2. Okay, many2 makes sense. Many2 string, okay. No, it's actually any2 because we have sepcaf. No, any2 won't work because sepcap takes all output. Yeah, any2 doesn't work here. No, it works. You just need to say many till any single till, and then you will receive unprocessed. Yeah, tab pack. So here you have sepcap, parser, left is parser. So you want to run parser t, this parser. And you want to say table, and you want to say later join, right? Because you will receive either. Which doesn't make sense. Wait, either. What's join doing here? Because run parser t returns monad and either. Amazing, like just amazing. I don't know why. So join run parser t. Why so many times Carmen? I don't understand. Carmen here was so many times. Join, and it will be either, and you want to lift this. Run parser T, and yes. And this is everything on unprocessed. What? How? How Carmen is again? Okay, let's give Era some proper show. Yeah, no deriving show. I will take show in my hands. Show Era, where show Era title header moments equals unlines map title header moments. Only for moments I want unlines as well. Unlines map show. Wait, and historic moments as well. I want it to have unlines show moments. Yeah. Because text, right. What about data text? Does it has unlines? Yes. Nice. Map show. Alright, because it's string. Do you have test show? Wait, data text. Is there something like show for data text? Text has show, but that's different. substrings, breaking predicates, searching indexes from instances, definition of acceptable data, searching. It doesn't seem contents, text, data text antenna for array, encoding array, encoding text lazy read. Okay, read is okay, but show, I don't have show. Data text show. Yeah, that's actually my is there equivalent of the show type class for data text. Library text show exists now and solves the problem. The show function provides also renders straight to text. Basic Prelude also has fewer dependencies than text show. If you want to use basic Prelude, save yourself compilation headaches by adding the following to the top of your source file. No implicit Prelude. Okay. So not issue, that's not a problem at all. Okay, let's actually text show. Let's include text show then. Text show. Cool. So what's in the text show? Print te. Model GP readme. Okay, print te. Just hello world. Okay. Text show. Okay, cool. There is class text show, and that's what we are going to use. Show b precedent. So show t, right? To a builder converts a value to a strict text. If you had defined this, it should satisfy. Show t. Yeah, convert it to the. That's nice. Text show is quite big. It's so slow to compile. Quite ridiculous indeed. wasn't you able to t text, yeah, map show. Let me fix this. Import text show. Right, import what text show class from which module? Wait, is it the module show? Well, it's a module text show. Wow, that's interesting. Text show, right? So what we are saying, text show, and what else we are saying? We also saying text show. We are saying show t. 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 Uh, 24. Do 33. Map, yeah. Map to show. Yeah, it's just on lines without a map. Not known, what? No instance for show lib error arising from it. It's from main. Show. No worries. Text show. Text show. Where do you see character? Lib error to string. Yeah, put strlen. Put strlen. T put strlen. Wait, there is no put strlen? Really? I'm pretty sure there is. IO. Yeah, I forgot about that. Show T. Alright, you also need show T. No, it's what I have. Leave expected type error to string. Actual type. Why do you expect to string? Because error bundle pretty is to string. Error bundle pretty. Import text parse combinators. No, mega parsec. Read error bundle pretty. String. Okay, I see your point. Tepak. But yeah, that's not. Yes, because you want also to export these functions. Oh, you can export. Actually, you can export two libraries as one letter. That's amazing. Okay, so something wrong with a historic moment. For some reason I decided to show T when it's not necessary. No explicit limitation for either show B. Why do I need it? Text show era. And why it's began only after... no, it's not began. It was before as well. $23. Yeah, there is no show B. I'm not sure why. Why do you want show B? What is show B? The value is converted to a builder, converts a value to a strict text. If you hard define this, it should satisfy. Show B precedent 0. Why is there a deriving text show? Text show, and then I want to define. How about that, Elon Musk? Seems like it doesn't work. Yeah. Wait, it should derive show. Can't make a derivative inside text show era. Text show is not a stock derivative class. AQ show. I can make a AQ show. No problems. Derive any class? What? I'm not sure. What's that. But also I'm not sure how to define show B. What's builder? Let's see. Builder is an efficient way to build lazy text values. There are several functions by constructing build, but only one to expect them to extract any data. So builder is data to text. How to construct a builder? Constructing builder singleton from character from text. Oh, so why want you from text as a default implementation for show B? Why do I need to define it? Show B is from text show T. Right, it should work. Only I need to show. Oh, yeah, it is working. Historic moment. Yeah. What? Historic moment. Yes, no warnings. Oh, so we have 5 era moments. Yes, so since we defined all of that, yeah, we can easily define multiple era stuff for And so that was error, and now we need file. Data file, errors. Yeah, it just errors. Instance text show file where show t file errors is the lines show map show t errors. Show b from text show t. Okay. What I'm trying to do, I'm trying to file, how to parse file, right? Oh, I already have file, parse, file. Actually, yeah, let's say file it's just a list of errors. Okay, no, let's say it's files. So we have parser for error, but what we need is separate by. No, here we actually can use sep by from start library. Sep by. Yeah, we have sep by in the alternative, right? Applicative, right? Applicative sep by. Yes. Applicative sep by. Super file sep by, and we have error, and we have space, and that's everything we need. Will it work? Right. File. Unexpected end of input for 38. Expecting quotes or white space. That's interesting. Right. No, I don't understand. Wait. Why is it expecting that? Yeah, I don't understand. What line? 38. Okay, so it expects. Let's first just try on one. Wow. For some reason it's not parsing. Wow, so one array is parsed, but when I say sep by array space, it's not parsing, right? Just to confirm. Error. So, yes, indeed. Parsing one array is okay, but using sep by to parse array separated by space for some reason doesn't work. Yeah, it's expect. For some reason it's expecting quotes. Oh, sep by parses 0 or more occurrence of p separated by sep. Return a list of values returned by p. But do I need to say end of file? End by parses 0 or more occurrences of p separated and ended by sep. Let's say end by, and let's say end of file. Perhaps I meant end by. And end of file. Oh, it's actually a mega parsec in the main library. Right? End of file. Wait. Yes. Yeah, I understand the problem here. No, I don't understand the problem. Oh, I understand the problem. We won't. Wait, we have something like that, right? It did work. Interesting. And it did work second time. Okay, so and the file here is actually what determines how much will be parsed, because otherwise it tries to parse the element parser and fails and returns this feather. Okay. To copy golden to input. Unexpected new line. Expecting or white spaces. 832. How? Oh, right. Wow. So it's actually fine there. Wow, so you see? So actually parsers give me a nice error showing where's the problem and what's the problem. So that's quite nice. Okay, so I think parsers is useful. Are useful. But I just think that they don't have enough useful functions. Like sep by was useful, yes, but we need to make distinction between functions that we need to create okay, already there are already functions that's like many-til that will take, so I don't think I need sep by. Oh no, sep by is implemented using many-til. So what we want two functions: sep by, which prioritizes parse. Okay, no, because if we specify parser, it's the end, because we cannot control insides of this parser. What we want is to have sep by that will output the list basically as replace mega parsec is doing. That's exactly what we need, except we don't want to have this weird behavior where because we want to have something like split, meaning that output will be elements, and if separators are coming consequently, like comma, we want to have empty tokens there. That's what we want. Also, we want to have a way to run child parsers easily. Yeah, like if we have text, we want to parse it inside. We want to parse it inside, yes, without doing like run parser t join. Or we can do it, but we need to write. Yeah, basically we need to write the function to parse text. But I'm not sure how the bind will works, like monad concatenation will work. So we have a bundle of error. Does this bundle of error properly bubble up? Because we used sep by, which just consumes input, and only after consuming it another parser can decide that the input is wrong. So maybe it would be useful, but we need to understand how position work, how states are working, to make sure that this relative offset of the child parser will be properly handled. And you know, I actually don't want to refactor it to split, using split, because again we have something like between figure brackets. It's not something that you can easy do with split, right? To do this you will need to split by open bracket, then the right result split by close bracket, and taking the first element of split will give you, and then the first, the other element of after second split you will need split again. No. Oh right, so for example our upper split, we have open bracket, close bracket. How would you split? There is no separator here. Right? There is no separator, so you can split by close bracket, for example. Okay, close bracket is quite good. Then you each of results you split by open bracket, and everything before is a header, everything after is a table. Table you split by the separator there, and each of them you split by. So one idea is to combine both advantages by using split only inside. Like for example, we used parser to parse what inside the figure brackets, and we can split what's inside figure brackets. We split, and then we can split again for historic moments, and that's all. But what should be done actually is just simply a function set by that will what? That's exactly the problem, right? It's not such a big. You even can create set by which accepts separator and parser, but it will fail if the stuff before the first separator will fail. Yeah, so sort of like you will first find all the text before the separator, and then try to apply parser to this chunk of text. And if it doesn't apply, you just say okay, like it doesn't work. That's all. Though it may be not universal. Maybe indeed having priority on the parser of the element is sometimes better. So that's what we need to do. We need to sort of specify who has priority, and we should have two versions of the function. Yeah, because honestly, the version of sep by and end by that is in the library right now is not really useful. It's like between parser and it's also not useful. Like I don't need between function. I just can write 3 statements in the do block. Open bracket, parser and end bracket. That's not hard. Actually, is that how between implemented? Yes. Open p close. That's ridiculous. Like between open close p and this. You can easily do this. What's actually useful is to have a function that will between okay, but functions that will find the end, find the text that matches end, and then try to parse in between process. So yeah, it's a nice idea to do for a new library. Or maybe we should extend the how do you call the replace? Yeah, it seems like replace mega parsec is exactly what I want. Just it's not developed as much as I would like, and has some, I don't know why they skip elements. Why not giving up empty string but skip element? Okay, I will end for now. I need to